We'll proceed in pseudo multivariate calculus. Pseudo multivariate calculus in which we are pursuing the discussion. Can I solve a problem? Can I solve a calculus problem through normal mathematics, not through calculus? Okay, if I have to calculate energy in a capacitor, then I'll start that power equal to voltage into current. Simple. And then current is charge by time. Power is energy by time. This proves that energy any moment the energy in the capacitor is voltage into charge. Okay, that way, very simple. And then we find that actually it is 1 by 2 into 1 by c into q square, or 1 by 2 into c into v square is the energy stored at the capacitor any moment where charge is q, or voltage across the plate is v. Okay, in that fashion, we are in phase of calculating surface area of a sphere. Mind-blowing brainstorming discussion is going on. Idea is that not to solve problem by problem that someone would go and crack in some competitive examination. The concept is that how to solve any problem that someone should go and crack. Anyway, in that fashion, the idea is to find what is the length of a vector. The idea is to find the surface of the vector, surface of a sphere through the length vector. What is length vector? We have talked in detail. If this is x-axis and this is y-axis, this is x-axis, this is y-axis, this is origin. This is x-axis, y-axis, this is origin, and there is a line on xy plane. An equation of the line in the xy plane is y equal to x square. Makes sense? It looks like x square though. Okay, okay, it is y equal to x square. As we go along, the curve is going like this. Now, what is the length of this curve? What is the length of this curve from origin? Okay, so what is the length of this curve from origin? This is the origin. What is length of this curve from origin to any point x comma y? This point is x comma y. This point is origin. What is the length of this curve when this curve falls in xy plane? Now, in that sense, instead of what is pseudo mathematics? Pseudo mathematics, pseudo multivariable calculus is instead of finding the length of this curve, find the length of a straight line. Okay, instead of that, consider this is x-axis and this is y-axis. I'm sorry, this is x-axis and this is origin, and the point in x comma y is here. In that sense, how to find length of a line section from origin to x comma y? The actual question is how to find length of a line section from origin to any point x comma y. But this is a curved line. Pseudo multivariate calculus is take the simplest form. Simplest form is it is a straight line. If it is a straight line, what is the length of this line from origin to point x comma y? If that is the case, then represent this as a vector. What is a vector representation along this line? And calculate the magnitude of the vector, then someone would get the net length of this line. Magnitude of vector from 0 comma 0 to x comma y. Vector representation is xi plus yj. Magnitude is x square plus y square square root. Then we saw that this curved line and a straight line, there is a difference. Difference is straight line everywhere y by x, y by x, y by x is constant, same. Whereas if it is a curved line, then everywhere y by x is different. Means y by x is variable. That I have to represent it in the vector. Otherwise, there is no difference between a curved line and a straight line. Only y by x is different everywhere. Then xi plus yj we took out x and it became I plus y by x j bracket close into x. Same thing. Now this vector represents the curve vector also. Okay, that is the concept. Now I'll replace this is called pseudo multivariate calculus. Now, how to find the length of the curve? That is, if someone has to find the magnitude of this vector, that is I plus y by x j bracket close into x. Okay, if it is division and numerator is dependent upon denominator, then it is dy by dx. And if it is multiplication of vector I plus dy by dx j, I transform y by x into dy by dx. I plus dy by dx j bracket close, this whole is a function over x because dy by dx finally it will come in x only. Whole is a function over x into x. X is independent component. Multiplication of two items. When one is independent component and one is dependent, it will be transformed into integral calculus. Now it becomes I plus dy by dx j bracket close into dx. Okay, if that is the scenario, then our vector representation of any curved line is I plus dy by dx j bracket close dx in xy plane. Okay, now bigger question arises is what is the surface area of a sphere? So here we were proceeding that what is surface area of a sphere? What is surface area of a sphere? Consider this is a sphere. This is a sphere. What is the surface area of this sphere? The surface area of a sphere, I take any point here called P. Any point P. The coordinate of P is x comma y comma z. If I take a vector from origin, then it is xi plus yj plus zk. Okay, that is the position vector of any point that is x comma y comma z. If that point if that point P is here, if that point P is here on this sphere, then I consider this surface. Any surface has two sides. Any surface has two sides. So we talked about that if I need to calculate length of a line, if I need to calculate length of a line, then I represent this line as a vector and calculate its magnitude, I get length of the line. If this line becomes a curve, if line this becomes a curve, again we represent this line as a vector and calculate the magnitude. Okay, for both of them, the vector is I plus dy by dx j into dx. Okay, similarly, if I have to find the area of a area, then it has two sides, one side and to this side. This is origin. Then I represent this as a length vector, this as a length vector. This length vector is I plus dy by dx j into dx. This length vector is again I plus dy by dx j into dx, or or it is I plus dy by dx j into dx started from xi plus yj. I can take y out, then it becomes dx by dy I plus j bracket close into dy. That is also okay. So if I try to find out the area of a surface, then this vector cross product with this vector will give the area of a surface. This vector is this vector is a vector and this vector is b vector. A vector, b vector. Now a vector is I plus dy by dx j into dx. Cross product with dx by dy I plus j into dy. Okay, that is the area vector. The cross product of two side vector give the area vector. Area vector direction is exactly perpendicular to the surface. Surface. Where line vector is along the line. That is the difference. It is not along perpendicular to the line, but area vector is perpendicular to the surface. So that is for guaranteed. Now, if this surface area which is flat and represented by two sides as vector A and vector B, if this becomes a curved surface, if it becomes a curved surface, then this straight line become a curved line. and this straight line also become a curved line. Still, we represent the both curved line of the surface as vector only. One is I plus dy by dx j into dx, and one is dx by dy I plus j into dy. Okay, now this cross product will give the surface area. Okay, then we saw that what we would do is that if I take a point P here, if I take a point P here, then I cut this point P in XZ plane, and from P I cut it in YZ plane, XZ plane, YZ plane. If I cut any sphere, if I cut any sphere in XZ plane and in YZ plane, or I cut this sphere in any plane, I cut this sphere in any plane. If I cut this sphere in any plane, then it will form a circle. This is XZ plane and this is YZ plane. This is XZ plane and this is YZ plane. Both where it is circle. Now in XZ plane, if I see this as a curve, and YZ plane I see this as a curve. If I take the cross product of this curve vector and this curve vector, it will give me the surface vector at that moment, at that point. If this is the point P here, if this is the point P here, if I cut in YZ plane and I cut in XZ plane, then at that point in XZ plane, if I XZ plane, if I cut, it will be a curved line. If I represent this curved line through vector, and then if I cut in YZ plane, if I represent the curved line in vector, if I take cross product of these two vectors, if I take cross product of these two vectors, it will give me the surface vector equation in algebra at that point P, and that is vertical at that point. Everywhere surface vector is vertical at the surface. Okay, that we have passed through. We have seen already. Please watch our video. Now, question is arising: if the cross product of any two, not required. Right now, we are taking a fundamental that it is a kind of rectangle. Please, someone should concentrate here. If it is a rectangle and if I do cross product of these two sides, then it gives the area of a rectangle. Instead of rectangle, if it is a parallelogram, if it is a parallelogram, means these two vectors are not at 90 degree. If these two vectors are at 90 degree, then doing the cross product of these two gives the area. If they are not at 90 degree, they are at this degree angle is not 90, still cross product will give the area, but it will give the area of a parallelogram. All right, I don't mind. Thank you very much. I don't mind. Can you do that? Okay. So in that sense, we will cut now. Okay, now we cut this in xz plane and we cut this in yz plane. This is x-axis, this is y-axis, this is z-axis, this is xy plane. In xy plane, this is x-axis, this is y-axis. Consider from x-axis there is another axis at 45 degree, that is alpha axis, and from y-axis there is another axis in 45 degree called beta axis. Alpha axis 45 degree from x-axis, beta axis 135 degree from x-axis or 45 degree from the y-axis. From x-axis 45 degree from x-axis is alpha axis, and from y-axis 45 degree from y-axis is beta axis. I believe it is all right. Now, in that sense, I can cut this. At any point P, I cut in Z alpha plane, and then I cut in Z beta plane. In that sense, can I again compute the surface area? Or I cut this in Z alpha plane, and then I cut this in YZ plane. Now, if I cut in Z alpha plane, Z beta plane, then it is again 90 degree. I cut in Z alpha plane. I cut in Z alpha plane. This is XZ plane. This is YZ plane. 45 degree. This is Z alpha plane. Z beta plane. I cut in Z alpha plane and YZ plane. Then it will kind of this plane are not 90 degree to each other. Still, whatever the circle I get, the curve length vector, and whatever the length vector I get in YZ plane, and whatever length vector I get in alpha Z plane, okay, if these two length vector, if I do cross product, will it give the surface area? That is the question that is arising. And in that scenario, if I cut it now, this is x-axis, this is y-axis, this is z-axis. Now, if I cut in xz plane, the circle will form in xz plane, yz plane, z alpha plane, 45 degree from x-axis, z alpha plane, xz plane, z alpha plane, yz plane. If it is z alpha plane, if it is z alpha plane, then how I can calculate the length vector? If I calculate the length vector, then I have to calculate length vector in z alpha plane, length vector in yz plane, just do the cross product, or length vector in alpha plane, z alpha plane, and length vector in z beta plane, do the cross product. Earlier we did cross product of a length vector in xz plane and yz plane. Calculating the cross product of these two gave me, calculating the cross product of these two gave me the surface vector. What is the length vector in z alpha plane? That is the question that we try. That is the solution. That is the situation that we try to tackle in the previous video. What is the length of a curve when this curve is in z alpha plane? If I take any point here, what are you trying to prove? I'm trying to prove that this circle in z alpha plane, consider the sphere is centered at the origin. The sphere I am taking, it is centered at the origin. If it is centered at the origin, half of the sphere is above the xy plane and half of the sphere is below xy plane. If I make a cut in z alpha plane, if I make a cut in z alpha plane, it will make a circle, and circle, the upper part of the circle, upper part of the circle, upper part of the circle is above the xy plane and lower part of the circle is below xy plane. Okay, if that is the scenario, upper part of the circle is above xy plane and below part of the circle is below xy plane. Now, idea is that what is the length vector representation of this curve in alpha z plane? In xz plane, I plus dz by dx, xz plane, I plus dz by dx k, bracket close, into dz. Okay, that is, what about in z alpha plane representation of length vector? Now, in that sense, we will go by with our fundamental. With fundamental, we will find the length vector, and we will see that length of this curve is indeed 2 pi a. A is the radius of sphere. If it comes like that, then our length vector is all right. Okay, that is the fundamental. What is the length vector of this curve in z alpha plane? If I take any point here, then I'll try to calculate length of this line from, consider this is origin. This is origin. Okay. Now from here, from origin, from here. Okay. Or someone consider. Okay, I believe I'm doing too much. Okay. So this is origin in the x alpha plane. I am trying to calculate the length of this vector from origin. Origin means it will go hit here. Okay. From here to any point here, what is the length of this vector? From there we will start. Right now it is a curve vector. So we will take a straight line from origin to any point here. This point here is x comma y comma z. Then this vector is xi plus yj plus zk. Now xi plus yj plus zk, where the magnitude of this vector is x square plus y square plus z square, a square root. That is the magnitude of this vector, x square plus y square plus z square, square root. Okay, but what we see here, the difference between, if I take any curve in z alpha plane, any curve in z alpha plane, then this curve in z alpha plane here, if I go along x-axis, then z is varying. Means every moment z by x is not constant. If I go along x-axis, y is varying. Okay, so y by x is not constant. Y by x means if I take xy plane, if I go along x axis, y is not varying because y is constant in yx plane. But in z alpha plane, y is varying, where alpha axis what I have taken is 45 degree from x axis. The equation of alpha plane, equation of line is y equal to x, that is in alpha plane. Anyway, we have found our length vector at xi plus yj plus zk. Take out x. It becomes I plus y by xj plus z by xk into x. Z by x is variable, where z equal to square root of a square minus x square minus y square as per the sphere fundamental. For the sphere, x square plus y square plus z square equal to a square. Z equal to square root of a square minus x square minus y square. If that is the concept, then I have taken, means if I take this a curved line, circle is a curved line from origin, consider this is origin of a curved line, and then I want to find the length of this line from origin to point x comma y comma z. I took as a straight line. Then the straight line representation as a vector is xi plus yj plus zk. But for a straight line, okay, z by x or y by x is constant. But for curved line, z by x, y by x, one of them or both of them may not be constant. In that sense, I have to represent this vector xi plus yj plus zk in term of y by x and z by x. If that is true, then it will be, I can take out x from xi plus yj plus zk. If that is the case, then it becomes I plus d by I plus y by xj plus z by xk, bracket close into x. Okay, now I am ready. I am in a position to change, flip division into differentiation and multiplication into integral calculus. This is pseudo multivariable calculus. Now here it will become I plus dy by dx j plus dz by dx k. Earlier it was I plus y by xj plus z by xk. It becomes I plus dy by dxj plus dz by dxk. Bracket close into x. Now multiplication of two items is coming. One item is I plus dy by dxj plus dz by dxk. This is a function over x because at the end everything will come in x only. Okay, why it will come in x only, that we'll see. And then into x. So it will transform into I plus dy by dxj plus dz by dxk into dx. This is the length vector of a circular line in z alpha plane. What is y by x? Y by x is related, means it is along alpha line. In that sense, y is varying the way x is varying because it is at 45 degree. Y equal to x, dy by dx equal to 1. Now in that sense, it becomes I plus j. I plus dy by dx is 1. I plus j plus dz by dx, that is minus x by square root of a square minus x square minus y square k. Okay, that is dz by dx into dx. If I am trying to calculate the length of this curve, actually I am trying to calculate the length of this full circle in z alpha plane. Okay, the length of the curve, then I have to take magnitude of this length vector. Then it becomes 1 square I square 1 square plus 1 square plus x square, that is dz by dx whole square, x square by a square minus x square minus y square. Okay, now when we are calculating along this line, then y equal to x. So along this line, y is varying like this. Now a square minus x square minus y square become a square minus 2x square. That's why I said that full will become function of x only. I plus dy by dxj plus dz by dxk, bracket close into x. This full became function of x only. Now it becomes more or less, it becomes I plus j plus minus x by square root of a square minus 2x square k. Magnitude if I calculate, then 2, 1 square plus 1 square, that is 2. 2 plus x square by a square minus 2x square. Here we were blocking yesterday, means in the past video. If I settle it down, it becomes 2a square minus 4x square plus x square. I believe it is all right. Okay, if I settle it down multiplied by 2, I'm sorry, I'm really sorry. Okay, dz by dx, z is square root of a square minus 2x square. dz by dx will become, dz by dx will become, I believe it will become 2x minus 2x. Okay, if I differentiate this with x, first I'll differentiate dz by dx. Z is square root of a square minus x square minus y square. Y become x. Square root of a square minus 2x square. Dz by dx, it become 1 by a square root of a square minus 2x square. Numerator will be 1 by 2 into differentiation of 2x square. That will become 2, 2, 2 into 2x into 1 by 2. It will become 2x square. 2x square. So net will become 1 square plus 1 square. 1 square plus 1 square. Okay. Plus 2x. Okay, because 2x, 1 square plus 1 square plus 2x whole square by a square minus 2x square. It will become 2 plus 2 plus 4x square. 2 plus 4x square by a square minus 2x square. If someone settle it down, it becomes 2a square minus 4x square plus 4x square by a square minus 2x square whole root dx. Now minus 4x square and 4x square numerator goes away. It becomes a square. Square root will become a by square root of a square minus 2x square dx. A I can keep outside. I'm sorry, that is not a, that is 2a square. 2a square. So 2a square square root. So a square root of 2 into a will come outside. It becomes 1 by square root of a square minus 2x square dx. That is the integration. Okay, that is 1 by square root of a square minus 2x square dx. Now I can take out 2 from the denominator. If I take out 2 from the denominator, then it will become 1 by square root of a a by a by 2, a by square root of 2 whole square, a by, I believe it was 2a, it was a square minus 2x square. 2 I am taking out. It becomes a square by 2 or a by square root of 2 whole square minus x square. 1 by square 1 by square root of a by square root of 2 whole square minus x square. Square root of 2 comes out anyway. And numerator we already have a square root of 2 into a. Square root of 2 gone. Now it becomes a integration of 1 by square root of a by square root of 2 whole square minus x square dx. This will come as sine inverse of x by a, where a is a by square root of 2. That will become x into a square root of 2 by a. Sine inverse x into a square root of 2 by a. Integration limit is, what is it? That is the where we were hanging the previous day. Now, if I'm trying to calculate, this is x-axis and this is y-axis. Okay, if I rotate it, this is x-axis, this is y-axis. In that sense, if I rotate it, then this is x-axis, this is y-axis. Now, in that sense, I have a circle in alpha z plane. Okay, now this is x-axis and this is y-axis, or this is y-axis. This is alpha line, 45 degree from the x-axis. If x is a, If x is a and there is one circular area line that is passing through because it is a sphere. If a sphere is centered at the origin, then on xy plane it will make a circular region. Makes sense? If there is a sphere centered at the origin, top hemisphere of the sphere is above the xy plane and bottom hemisphere of the sphere is below xy plane. In that sense, on the xy plane, it will make a circle. So if this is x and this is y, this is xy plane, it will make a circle. If it makes a circle, then if it is passing at point A in xy in x-axis, then in alpha, it will pass as A cos 45 degree. I believe it is all right. Okay, it will pass, this is 45 degree. It will pass at a line that will be smaller. It will pass that line which will, I mean, it is a circle, line is same, I'm sorry. So if I say like this, then x is 0 here, here it is a, that is the radius. If it pass like this, circle is passed like this, then alpha x is this length will be a. But if I take this component on x-axis, this will be a cos theta. I believe it is all right. If a circle is passing on the xy plane like this, then it is passing x-axis at A. It is passing the alpha plane where this length is A. When I take this as a component on x-axis and take this component on y-axis, then component on x-axis will be A cos theta, A sin theta, A cos theta, where theta is 45 degree, it will come as 1 by square root of 2. So on x-axis, if I take this alpha line, what is the limit of x in this integration? We found that our net calculation is a integration from the limit of x from lower limit to higher limit, and integration what we got is sine inverse x into a square root of 2 by a, where x, if I take this x, then x will be, this is, we are taking along alpha line from here, and alpha line will go back here. Then alpha line here, if we take x, then it will be x by a square root of 2, and this side also minus x by a square root of 2. I believe it is all right now. So limit will be minus a by a square root of 2 to a by a square root of 2. Now we can put now sine inverse x into square root of 2 by a. Lower limit is minus a by a square root of 2. Higher limit is a by a square root of 2. If I place in place of x a by a square root of 2, then higher limit, it will become sine inverse 1. Sine inverse 1 is pi by 2 minus pi by 2. Pi, it will become pi. A is outside. Pi A is the circumference of a circle in alpha z plane, z alpha plane from one end to another end. Full length is 2 pi A. Means our equation is perfect. Calculating the line length in any plane, not only in zx plane or zy plane, in any z alpha plane, it is all right. If we go with our length vector, that is I plus dy by dx j plus dz by dxk into dx. Okay, so that is the fundamental. Now, concept is that can you realize now what would be surface area when one plane is z alpha plane and one plane is zy z beta plane? Okay, then it can, in that sense, our area vector is one length vector in z alpha plane cross one vector in z beta plane. Okay, if I do cross product, that becomes area vector. In z vector, it is I plus dy by dx j plus dz by dx k into dx. In beta z plane, we will take out y now. It will become dx by dy I plus j plus dz by dy k into dy. I'll do, someone has to do cross product of these two. Cross product of these two vectors. One vector is I plus dy by dxj plus dz by dxk dx. Cross product dx by dy I plus j plus dz by dyk bracket close dy. If someone do the cross product of these two, then he will get area vector. Calculating the magnitude of this and then integrating it, then someone would get the surface area. Anyway, if that is the case, then what will be the integration? First, we will settle it down. The vector I plus dy by dx. Since it is along alpha z, dy by dx will be 1. I plus j plus dz by dx. Now y will remain, just we will make it dz by dx. Okay, dz by dxk, because y will be there. I plus j plus dz by dxk, bracket close, dx cross product with dx by dy along the beta line, where the line equation is y equal to minus x. Dx by dy will be minus 1. Here it will be minus I plus j plus dz by dyk into dy. Now someone has to calculate the cross product. Cross product is I plus j plus dz by dxk, bracket close, dx cross product with dx by dy I plus j plus dz by dyk, bracket close, into dy. Someone calculate what is the limit. Now if someone calculate the limit, then x will be again minus a by a square root of 2 to a by a square root of 2. What about y? Y is a circular region. Y is dependent upon x. Now, in that sense, y is typically, if the when we are taking limit, the limit will come on xy plane. This is the 3D surface area we are trying to calculate. 3D surface area on xy plane, it is a circle. Please watch our previous video. Many times we have talked that on xy plane it will form a circle. Integration of dx dy, that will be resultant at the end. It will be circular region on the xy plane. But since we have taken alpha axis and beta axis, alpha will be, for alpha, x will be minus a by a square root of 2 to a by a square root of 2. And beta and y, typically y and x, they are related as far as circle is concerned. X square plus y square equal to a square, y equal to square root of a square minus x square. So limit will be minus square root of a square minus x square to a square root of a square minus x square. But we have taken beta axis, along which we are taking the y. It will be 45 degrees. So it will come as y equal to minus square root of a square minus x square by square root of 2 to square root of a square minus x square by square root of 2. Why it is like that? Someone has to prove. We will talk in the next video. I believe next session. It will be too much for now. So x limit is minus a by a square root of 2 to a by a square root of 2, and y will be minus square root of a square minus x square by a square root of 2 to a square root of a square minus x square by a square root of 2. I plus j plus dz by dxk, bracket close, dx cross product minus I plus j plus dz by dyk, bracket close, dy. It will come as at the end dx dy. Whatever cross product comes as a vector, calculate the magnitude, that is ith component square plus jth component square plus kth component square root, and integrate like this: x minus a by a square root of 2 to a by a square root of 2, and y minus square root of a square minus x square by square root of 2 to square root a square minus x square by square root of 2. Is it required that I take beta axis only? I can take yz plane directly. Then take it. Then limit of the y will be minus square root of a square minus x square to a square minus x square root of a square minus x square. In that sense, dx by dy, what we have taken in another length vector, will be 0. It will be cross product of I plus j plus dz by dx, bracket close, dx cross product with j plus dz by dy k into dy. That ith term will go away because dx by dy will be 0 along the y-axis in yz plane. Someone can proceed calculating the surface area. Mind blowing, amazing. I'll try, otherwise we'll see y in the beta plane, it is minus square root of a square minus x square by square root of 2, and a square root of a square minus x square by square root of 2. Okay, Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.